Hello teacher, hello guys. My name is Santiago Lopez and today I talk about the formation of dioxins and furans during municipal solid waste gasification. The dibenzopredioxins, the abbreviation is PCDD, and the plurichloronated dibenzofurans, PCDF, constitute a group of persistent pollutants that inexorably originate from thermal and combustion operations. The chemical and toxicological properties of these compounds rely primarily on the number and position of chlorine atoms bound to the two aromatic rings. Certain dioxins and furan isomers are well known for their toxicological features. They exert carcinogenic and mutagenic effects. Once PCDD and PCDF enter the atmosphere, they are subject to chemical, physical, and biological transformations, ultimately contaminate the soil, water bodies, and sediments. Okay, the main dioxins and furans generation in the environmental are the ones you see on the board, like the incineration of PVC and plastics, thermal power plants, and the main generation that the document focuses is the waste incineration. Industrialized nations generally employ incineration and gasification to generate energy and to trade waste. The current lack of landfills or even their closure has made solid waste treatment by thermal process an attractive strategy. Moreover, both gasification and incineration reduce waste mass and volume, destroying hard zone residues, and recover energy. Waste incineration is one of the most frequently employed technologies to process waste thermally, and it can be applied to several types of materials. Research in dioxins furans formation has targeted MSW, is municipal solid waste, um, incineration, elevate dioxins concentrations account in the fly ash and gas flow during the incineration process. Dioxins and furans generation is a complex phenomenon that involves multiple solid and gas phase reactor between minimum amount of reagents. During thermal waste destruction, dioxins and furans are known to arise together with combustion gases, fly ash, and even slag. Researchers have examined two main hypotheses regarding the mechanics of PCDD and PCDF formation during combustion, namely the de novo synthesis, that is to say, production from elemental carbon, and dioxins and furan generation from precursors. Uh, okay, now we will see the experimental section. A moving group gasifier was employed to evaluate dioxins and furans emission during gasification, as you can see here. The equipment was fed with municipal solid waste to generate and subsequently burn the synthesis gas. The device was fed manually. The combustion system was controlled manually as well. The gasified municipal solid waste was probed by a landfill that receives waste collected from 14 small municipalities of the Brazilian states, and there was used as gasification agent. Okay, the municipal solid waste fed into the gasifier was grossly shared and no additional thermal was done. The gravimetric composition of the municipal solid waste is present on the right, and the characterization of MSW is demonstrated in present on the left. Um, okay, the characterization and classification of the ash produced during gasification were performed according to the standards referenced by the Brazilian Association of Technical Standards and the Standard Methods. The method 0 to 3 of the United States Environmental Protection Agency was used for sample collection and analysis to determine polychlorinated dibenzopyrdioxins and polychlorinated dibenzofuranes from municipal waste combustors. Combustion gas samples for analysis of dioxins and furans were collected from the exhaust stacks of gases originally in the system's gas combustion chamber without any previous treatment. The impingers were weighted before and after sampling to evaluate the mass of condensed water. To sample dioxins and furans, a trap was used with 40 G of XAD2 resins. A glass fiber filter was also used at the beginning of the experimental setup to retain particles. Okay, the results and analysis. The dioxins and furans were sampled in the combustion gas flow. The conditions of the sampling are presented on screen. Okay, the chromatographic assay conducted for 3 samplings of municipal solid waste gasification in a mobile grid. Gasifier furnished the mass of dioxins and furans generated in each case, and the results are seen on the screen. The results on the table revealed that the tear sampling contained the largest mass of dioxins and furans. This was a consequence of alteration in operational condition along gasification. The system feeding and combustion were controlled manually. The process was stable during the first 2 collection stage, but change that occurred during gasification modified the process temperature. This challenge, this change, these changes are excess air present in the chamber during combustion and variation in the amount of atmospheric air that entered the gasification chamber. This culminated in different conditions over time, favoring dioxins and furans formation. Account for the volume employed during the assay is a one can obtain the emission of dioxins and furans analogs corrected with 7% oxygen for comparison with the limits established by the emission standards. Finally, the maximum volume allowed by the Brazilian legislation is 0.5 ng TQM3. Okay, the conclusions. In conclusion, even considering the tier samplings, the dioxins and furan emission lie below the maximum value allowed by the current legislation. The main dioxins and furan emission from the gasification in the mobile grip reactor was 0.28, expressed in toxicidad total equivalente. Thanks. Any question?